Source Code Group Weekly MR walkthrough, and Igor, please take it away.
Hello. So my merge request is quite small, and but at the same time, I noticed that it touches quite large topic about replication and database replication. And I wouldn't say that I'm ready to discuss it in depth, but I had to touch this area and decided to share some details and findings that I noticed, and maybe it will be useful for you as well. So the problem is our database is replicated. Like write request, mutable request, they go to the primary, and then database is replicated to the replicas. So the read requests could be read from the replicas. It is done for scalability, availability, and usually it happens really, really fast, the replication process. But for example, when a Postgres version is updated, migrated, we have some feature tests, integration tests, when a replication lag is the period at the time between the moment when primary receives some data, receives some changes, and the moment when these changes are successfully replicated to the replicas. So the replication lag is configured to 1 minute, to the large period on purpose, just to see whether we have some failures or we have some bugs that shouldn't happen. So some of the tests failed. For example, snippet creation failed. And why did it happen? Let me, maybe not here, just a second. So when a snippet is created, a record in the snippets table is created. So it's successfully created. And then after that, GitLab RPC is performed to create the snippet repository, the code that actually stored in the snippet. So the snippet record is created and GitLab RPC is performed. On the other hand, GitLab RPC performs some internal API requests. And those requests, they are unaware that this snippet record has been created, because the server thinks that it can read from the replica, but due to the replication lag, the snippet record isn't yet visible. So we receive an error that we have a repository error creating a snippet, just because GitLab RPC can't be performed because internal API request failed. So with this issue, we have a couple of issues in our code base. For example, just one detail. Sean, I see your hand is raised.
Sorry to stop you there, Igor. But so you're saying that the reason it fails is because GitLab is trying to read from the replica, which hasn't yet received the update, instead of reading from the primary.
GitLab performs an HTTP request, and GitLab Rails thinks that that it can read from the database replica, and the snippet is not yet created there because it's on primary only here.
But if it did read from the primary, there wouldn't be this problem, right?
Yeah, that would be a problem.
Okay. I think Patrick's got his hand up.
I will. So I think you already kind of answered the question. So what would happen when the replica is then up to date? Then we wouldn't have this error anymore, actually.
Yeah,
Okay.
the replica will be up to date. Yeah, and usually it's not a problem just because this replication happens like really fast. And yeah, even though just a second, yeah, even though it like a small time passes here, but
Mm.
I believe we didn't receive this error like in real world scenarios. Yeah, but when we set the replication lag to absurdly large like
Times.
period, yeah, we
Okay.
received this error. So yeah.
Yeah, then it's just like an error that could happen like between like that 1 minute that there is the lag, and then the error would, okay, got it.
Yeah, just yeah. And as Sean mentioned, yeah, if we read from the primary, this error wouldn't happen, but we cannot just redirect all requests to primary because it would increase the load, yeah, and kind of diminish the purpose of having replicas. So we should have some smart solution like here. I mean, not like smart solution, but something that would also wouldn't have the performance implications. Yeah, and one of the possible solutions is to use the primary database instead, exactly for this like use case. But also what I've noticed, yeah, like some interesting feature that we have is like it's called like sticky behavior, yeah, like sticking to the primary database. Yeah, for example, in order to fix like some common problem for replication lag, for example, user performs some changes, yeah, for example, updates the profile and then reloads the page, and user performs this update request, then reloads the page. The changes are read from the replica, but due to the replication lag, the changes haven't been applied yet. Yeah, so user thinks that there's some data loss. Yeah, and it's a common problem with the replication lag, and it usually like one of the solutions would be letting a user letting user read the changes that was just applied from the primary, and all the other users, they read from replicas. Yeah, so just like we let the user read their own requests, their own changes. And in order to fix this problem, we stick if necessary. Yeah, it's called like this. If a write has been performed, we stick. And what does it mean? We write in the Redis that this particular user performed the write, yeah, performed some changes. And for 30 seconds, that user will read from the primary database. So they see the changes that they just performed. Yeah, so they will see the changes that they just performed. But the problem that we had, that for internal API requests, they were unaware, even if we stick to the primary database, primary node, the internal API requests, they wasn't aware whether they should use primary or not. This is why this change has been introduced. Yeah, that we mentioned that we should stick to the primary if it was set before. Yeah, so this change was introduced. It didn't fully fix the problem, but at least now this scenario was possible. We tried to create a snippet. We created one. A user like performed the write. This stick logic has been performed. So now a user is ready to write from primary, but request still fails just because, sorry, I'm confusing a bit, but yeah, request fails, but just because we stick to the primary, now we can try to create a snippet again. And when we try it, it's successful. So like it requires like 2 actions. Yeah, try to create request, a snippet, request fails, you try to do it again, it passes. Yeah. So, but it doesn't fully fix the problem, but yeah, it's a bit better than before. So now we need to tell we need to like fix this problem and create the snippet like from the first try. So we explicitly say that we need to stick to the database just before stick to the primary, just before the Gitly RPC is performed. So snippet record is created. We explicitly say that we stick to the primary, then Gitly RPC is performed. Now, internal API is aware that it should read from the primary, and so the snippet record is found, and everything is fine and successfully. So the snippet is successfully created. So this is kind of the problem, and yeah, it requires a couple of lines change, but yeah, it requires some long explanation that yeah, is probably confusing. Yeah, but I'm ready for the questions. Yeah, Robert.
So that disconnect between the first request and the one that then happens off of Gitly has cropped up before, because I think it was only like a year and a half, 2 years ago that we could actually connect those 2 requests even together. So the request in the internal allowed endpoint had a different request ID to the original one that caused it to be triggered. And so no one could tell what the whole request stack was. Something that might crop up is the Gitly actually performs that in a loop, as in it will call internal allowed in like a nested loop down itself, so it'll keep calling it into it again, if that makes sense. So like it can call, you've got your request to Gitly to internal allowed to Gitly to internal allowed, and there's like a couple of scenarios where that happens. So I don't know if that's going to play into this or not, but yeah, it's interesting to see that we've sort of had this totally different problem with the same cause, that those requests are totally unrelated to what originally called them.
Yeah, what I can share here is only that it also was one of the it was one of the possible solutions. Yeah, it's to actually use the correlation ID. Yeah, as I understand it, yeah, the problem that you're describing, that 2 requests were like unrelated. Yeah, but they will likely have the same like correlation ID now, just because
they do.
We set
it's much better. It used to be impossible to actually tie those requests together. I had to do it for an incident once, and it involved looking at logs and guessing how long it took between the requests and stuff like that, and trying to figure out the right one. So yeah, I think that the way that it's been done makes a lot of sense, though. I think that's sticking it based on the user rather than the request makes sense.
Yeah,
it should be more resilient, I think, especially because of that thing where it can be called multiple times in itself as well. I think it makes more sense to have the check happen on that end rather than just sort of hoping it's all still technically the same request.
Yeah, and I also think that it's like simpler to do it like this, because with correlation ID, it's more like some separate sort of magic. So
yeah, and it's a bit of a nightmare to keep this part of the code base in your head as well. Like when you're trying to figure out the exact call stack of something to Gitly, to internal allowed, to whatever, to back to itself, to a different part of internal allowed. That's really frustrating to sort of sit there and try and remember exactly how many steps it's doing. And so yeah, anything that keeps it simpler is good.
Yeah, and probably I was confusing because I missed one important part. Yeah, regarding the sticking. It actually happens like this part stick if necessary. It happens after the request. Yeah, so when the whole request, whole logic performs, yeah, we analyze whether a write was performed during the whole request. So, so this is why this line is necessary, just because we perform all the logic and even this part, and only then we stick to the primary. But in order to perform the correct HTTP internal API request, we need to stick before the internal API request is attempted to be performed. So yeah,
I think one solution that I'm assuming was discounted for performance reasons is just to make sure every request from internal allowed reads from the primary. But this endpoint is hit more than pretty much anything else on the entire application, I think. So that would put a really weird amount of load onto the primary database. So I think this is definitely the best way of doing it.
Yeah, and considering that we sometimes disabling features, just I remember that we disabled one of the features, I believe, right into the statistics, just to to read from the replica, just to avoid any write requests in the internal API endpoint. So that would be a shame to return to.
It gets exponentially slower too because of that thing where it calls itself. So anything that makes the internal allowed endpoint slower, the like performance curve goes like this because it increases for every single extra request that it performs. So any tiny increase in time is like at least double that. And I've never figured out exactly how many times it can call itself. I think it's around 3, but it could be more, and it might have changed since I last looked at it as well. So I think there's certainly some interesting performance problems around that. But yeah, I think this way of doing it makes a lot of sense. It's interesting that he's using Redis to do it as well. I think that makes more sense than locking database records or storing it in Postgres and that sort of stuff.
Yeah. Oh, and Sean, you have a question?
I actually have 2 questions, but I think if you do this, you get some other emoji. So I'll just ask one in case someone else wants to ask one in between. So the first question I've got is: so this was raised initially as a snippets issue, and I think you were alluding to the fact that this is only happening in our test. With our test, right? Like we haven't had this reported in production, but it could happen, I guess is what we're saying. But is it okay? So, but could this problem happen? I think you've kind of half answered this, but can this problem happen when the flow is like this? Like we first update the Postgres database for some reason, then we ask Gitly to do something, and then Gitly will update the database as well, or not necessarily. Oh yes, Gitly will read from the database, right?
Yeah.
Okay, so it could happen on almost any change where we write something first to the Postgres before calling the Gitly RPC.
Yeah, I think so. And for example, this change, it's applied to all the internal API requests. Yeah, so it's fixed for all internal API requests. But the cases like this, they should be resolved like individually. So if we receive some other problems like related to it, so we will also need to explicitly say that primary should be used during some GitLab RPC. If that makes sense.
And also, if we suddenly start to see, for example, a big slowdown, we might, in now, or because this has already been merged, then we might consider, we might come back and look at this, what's happening in internal allowed here, right? Because maybe that could be a culprit.
Yeah, but at the same time, like this call is like it guarantees like correctness and also guaranteed correctness that if, for example, replicas are not yet up to date, it ensures that primary that we read from primary. So yeah. Maybe I also wasn't clear that this request doesn't like always ensure that we read from primary. Yeah, it tries to find some up-to-date replica first, and if it can't find it, then we use primary. But first it tries to find caught up replica.
Okay.
Yeah.
We're almost at time, but does someone else have a question before I ask my second one? Okay. Igor, if you wouldn't mind just quickly, just for the last couple of minutes, click on the snippet repository file.
Snippet repository file.
The model file. Yeah, that's it.
Yeah, like this one.
Yeah. So I was just wondering what's going on with this GitLab exclusive lease stuff here.
Like this one, yeah.
Yeah. What is that? Was that something you can't answer in 1 minute?
Yeah, I need to quickly just a second. So I would call it like a lock on the record. Yeah, we just make sure that
a database lock.
It's not a database lock. It also uses Redis. Yeah, so it's our like explicit lock on some operation. It doesn't log the database record. Yeah, but like two consequent actions. Can it like we lock this exactly like this block for this snippet ID? I believe it's done not to create two repositories, not to commit files twice to this for this exact snippet, because GitLab, probably that the reason GitLab doesn't respect database locks. So this is why we need to explicitly lock it in the Redis. And so if, for example, two consequent requests for updating the snippet ID, like for performing GitLab RPC for this snippet ID, then it won't be performed. And like this code, maybe it's not very obvious or clear exactly for this use case, but I remember that we have it in the merge service. If I can create it here, exclusive lease. Yeah, for example, merge service, merge is a merge request. So if, for example, two engineers, two people, two users try to merge the same merge request at the same time, we don't want to perform this operation like twice. We want to like lock it just before we merge it. Yeah. And this is atomic operation. So we try to obtain the lock. If two users try to obtain it at the same time, then one of them will fail.
Great, thank you very much, Igor. That was super interesting. Really, I didn't have any idea.
Sorry if I'm too slow today. Yeah. But...
No, perfectly fine. Thank you very much. I have a call that's already started, so I have to go. Sorry. Thank you very much. I'll upload the recordings. Oh yeah.
How do you get the fireworks in the background?